Welcome back, pre-calculus students, for your last 6.5 video. We kind of, as a department, agreed not to grab examples from the book, but again, this one was too hilarious. So what it says is, believe it or not, the drive-in movies that were so popular in the 50s are making a comeback. I don't know what they define as a comeback, but apparently they are. If you arrive early, you can park in one of the coveted center spots. But if you arrive late, you may have to park very close and strain your neck to watch the movie. Surprisingly, the maximum viewing angle, not the most comfortable viewing angle in this case, is actually very close to the front. Assume the base of the 30-foot screen is 10 feet above the eye level. So here's you in your 1980s, like, I don't know, sedan or something like that. And it's saying you've got this angle alpha, which is the whole thing, from the very base of the ground all the way up to the top of the screen. Theta is just the screen, and beta is just the angle it would take for you to stare at the supports. Use the inverse function concept to find expressions for angle beta and angle theta. Well, let's start here. What we can say is we know the ratio is we're going to look for in terms of x. We want everything to be about how far away you have to park your car in order for this angle to happen. So what is the ratio that relates x, and in this case the height of 40 feet is the total, and this tangent. So we can say is alpha equals the tangent of, the tangent of alpha equals 40 over x. 40 is the opposite, x is the adjacent. Similarly, the tangent of beta equals, actually let's do this one through to completion. We're looking for an expression of terms of alpha in terms of x. Right now we've got tangent alpha, so we're going to take the tangent inverse of both sides. When we take the tangent inverse of the tangent of alpha, we're just left with alpha equals the tangent inverse of 40 over x. In a similar manner, you can generate the fact that beta will equal the tangent inverse of 10 over x. The only difference is the opposite height just being 10. So those are our answers for part A. Part B is asking, what is the expression for the viewing angle theta? Well, our viewing angle theta is going to be whatever alpha is minus whatever beta is. So since theta equals alpha minus beta, and we've got expressions for alpha and beta, we're just going to plug them in. The tangent inverse of 40 over x minus the tangent inverse of 10 over x, which means we now have an expression for the viewing angle theta in terms of nothing but the distance from the base of the car, from the base of the screen to the car itself. What they want us to do at this point is use a calculator to find the viewing angles theta for the distances of 15, 25, 30, and 45 feet. I'm going to use my graphing calculator. I'm going to try to use it in a little bit more efficient way than just typing in a whole bunch of these. So I'm actually going to type in the equation right into here. My y equals second tangent inverse of 40 divided by tangent x. Use my trace function to plug in x values, but I don't want to hit my normal window because I'm at zoom 6, so I'm going to hit window. I'm going to guess. The closest I could get is 0 feet. That would obviously put me right underneath the screen. I don't know about how far. I don't know, maybe something like they're asking for a maximum of 45 feet, so we could do something like 60 feet. And we'll go up by, we'll get 10 slots, so we'll go up by 6 feet. Now, my y minimum is going to be the angle that's created, my viewing angle. Certainly we can go from 0. Largest, I would imagine, is something like, I don't know, 75 would probably be breaking your neck to watch a movie. And we'll go up by 5s. Maybe, actually, let's go up by 8s, just to give it a little more, little nicer y-axis. And let's see what our graph looks like. Kind of comes out and it's slowly starting to go down. We could have made it a little bit prettier, but for the most part we get what we're looking for. We have our max and this is going up. We're certainly not going to nudge down below that. For feet, so what we can use now is our trace. If we need x values of 15, 25, 35, and 45, those will kick out our thetas. All we're going to do is plug them in. You hit trace, and it'll ask you x equals, and you type in 15. You get a theta of 35.75. Repeat the process with 25. Enter. 36.19. With 35. And enter. 32.86. And finally with 45. Enter. 29.10. Now, in order to figure out the max, all we're going to do is hit second, calc, maximum, and it says left bound. For those of you who haven't used this, what we do is our peak's right about here, so we're just going to make sure we go somewhere to the left of the peak. We can hold this down. Oh, sorry, this is the most riveting piece of video you've probably seen all week. Hit enter. Right bound, we're just going to go to the right of the max. We're just going to get past this horizontal line. And enter. Guess it's just somewhere in between those two. As long as you get a little bit inside, you should be fine. When you hit enter, it's doing a little calculations. And you get a max of 19.99999, and that's probably close enough to 20 feet. And it looks to be about 36.7. So our max becomes a viewing distance of 20 feet away, which gives you a max of 36.87 degrees. That's it for inverses. We'll spend a lot of time in class, at least I know I will, going over this content. Hope you have a great day.